Greedy technique solves an optimization problem by iteratively building feasible solutions. We have to understand what is meant by optimization problem and what are feasible solutions. Okay, it says this greedy technique. If a problem is given, what this greedy technique does is it will start building the solutions step by step. Okay, and the step by step solutions what you get, we call it as feasible solutions. Hope you can see the mouse pointer. The step by step solutions that you are going to generate, they are called as feasible solutions. And finally, once you obtain the final solution, that solution we call it as we call it as optimal solution. So the third point, you can see the third point, it is called as optimal solution. So a problem is given, you have to start step by step, you have to go step by step. In every step, whatever solution you get, we call it as feasible solution. And finally, the solution what you get, we call it as optimal solution. Okay, is it clear? Yeah. Then look at the second point. It always makes the choice that seems to be best at that moment. In every step, the greedy technique will choose the best solution at that point. Okay. To make you understand this, I'll take one problem example. Consider a currency change problem. For example, consider there are unlimited supply of all the denominations from rupees 1 till rupees 2000. See, you know that in India, Indian rupee, we have denominations from 1 rupee till 2000 rupees. So the problem is, if you have unlimited supply of those denominations, you have those notes or coins, plenty of notes or coins, then the problem is like this. What is the minimum number of denominations needed for one particular amount? For example, 3,385. If I tell you that, what is the minimum number of currencies or what is the minimum number of denominations that you need to come up with this amount, 3,385? So that is the problem. So what you do at first, when I say that you have to minimize the number of currencies. So what you do is you first choose the biggest currency. The biggest currency is 2000. We have a currency of 2000, isn't it? So we don't go for 500 or we don't go for 200 or 100. Directly we go for 2000. Okay, since my amount 3,385, it is greater than 2000. The first choice will be I will pick 2000. Okay, so on the right hand side, what you say is 3,385 minus 2000. You are left with 1,385. Okay, so in the second step, what you do, you are left with 1,385. Next, the currency or the denomination that you choose is, you cannot choose 2000 because it is greater than 1385. You have to go with the lesser amount of denomination, that is 500, isn't it? So I will take one 500, so it becomes 2500. From 1385, I will deduct 500. The remaining is 885. Okay, next 885 remains. The next denomination I will choose is one more 500 I will choose. So 2500 and 500. So similarly, out of 885, you deduct 500. The remaining is 385. Next. So remaining 385 is there. Now I have to choose the currencies for this. Which is the biggest currency? I have to go for 200, the currency 200. So I'll add this 200. Okay. So I'll deduct 200, the remaining is 185. 185 remains, the biggest currency that I can choose is 100. 185 minus 100 is 85. Come to the next one, 85 remains. 85 remains, so I have to choose 50. 50 remains in the next step. 50 remains in the next, in this step, in this one. 85 minus 50, the remaining is 35. 35 remains. So for 35, I have to choose 20. The next biggest currency is 20. So 35 minus 20 is equal to 15. So 15 remains. So for 15 rupees, the next biggest currency is 10. I will choose 10. 15 minus 10, the remaining is 5. The next biggest currency is 5 rupees. I will choose 5. And 5 minus 5 is 0. So what we got here is, see, the final set, what we look at is, this is the set of minimum currencies that are needed, the set of minimum currencies that we need to form 3,385 rupees. So we call this as optimal solution. Okay, and the intermediate steps, the first step, the second step, the third step, similarly all the intermediate steps, see, these are also the solutions. In every step we are getting some solution and we are coming near to the solution. Okay, and we call these solutions as feasible solution. Okay, now finally what we got, we have got an optimal solution. And in this problem, our main task was to minimize the number of currencies, isn't it? So since we are minimizing the number of currencies, since the optimal solution is focusing on minimization, we call this problem as minimization problem. This is called as minimization problem. There's one more kind of a problem, we call it as maximization problem. We call it as maximization problem. Hope you understood that problem. I will now take one DA problem and we will try to solve using a greedy method. Any doubts till this? You can use your chat application. You can unmute your mics. You can ask the questions. So if there is no doubt, let us keep the doubts at the end of the session. We will continue. The first problem that we are going to look at is knapsack. The first problem we are going to look at is knapsack. Please don't use the markers and don't try to scribble on the screen. Okay, yes. The first problem is knapsack problem. Let's first understand what is meant by knapsack. Okay, on the screen you can see a diagram. Please don't scribble on the screen. So consider there is a bag. Knapsack means a bag, a container or a bag, something like that. Okay, and these are the objects. Item 1, item 2, item 3 and item 4 are the 4 objects in this example. And each item, it contains some profit. Below you can see value 1. V1 means it is a profit value. Some $42 is the profit that is given. And W1 is the weight of this item. Okay, so it is the weight of the item and associated with that is the profit. Profit is 42. Similarly, every item has a weight and a profit. So W3 is the weight of the item 3 and V3 is the profit of the item 3. Okay. Similarly, item 4, weight is 5 and value is 25 or the profit is 25. Now the problem is there is a knapsack given, there is a container or a bag given and its capacity is 10. Its capacity is 10 and what you are supposed to do is you are supposed to fill these items in this knapsack, in the bag, so that the maximum profit you should get from this. Okay, for example, if I put item 1 in the bag, so what happens, the profit what we get is 42 and the weight of this item is 7, and out of 10 if I deduct 7 then 3 remains. Let us consider it as kgs. So 3 kgs remains. Total is 10 kg, and 7 is the weight of this item that I have put in this knapsack. Okay. Now there are only remaining 3 kgs. Okay. Now is there any other item with 3 kg? Yes, there is one item called as item 2. So this is having 3 kgs. So now this item can be put into this knapsack, isn't it? So totally weight 7 and weight 3, totally it becomes 10 kgs. So I can put two items in this knapsack. Now what will be the total profit? Profit is 42 plus 12. Profit is 42 plus 12. Okay. So now what is 42 plus 12? It is 54. So total profit is 54. Now the problem is there any other combination of the items that I can put in this knapsack so that I can increase the profit? Got it? The problem is there any other combination? Is there any other combination of the items that I can put in this knapsack so that I can increase the profit in the knapsack, provided that the total weight should be lesser than or equal to 10. I'll take one more example. We can put item 3 and item 4. Item 3 is 4 kgs, item 4 is 5 kgs. Total it becomes 9 kgs. So 9 kgs can be fit in the 10 kg knapsack, and the total profit 40 plus 25, 40 from item 3 and 25 from item 4. So this one, what is the total is 65. So totally 65 profit I will get from item 3 and item 4. Okay, so that means we have got a combination of item 3 and item 4, which gives us the maximum profit. Okay, so now, so this is the problem. So is there any other combination apart from that? So we have to find that. So for that, there is one method. We have to follow that method and we have to come up with the solution. And this solution is the example for maximization. So in the previous slide, the coin problem is the minimization problem, because uh, we have to minimize the number of currencies or the denominations, isn't it? So similarly, in this example, we have to maximize the profit, and since we have to maximize the profit, so this is called as the maximization problem. Okay, let us move to the next slide. So just have a look at the points, then we'll take example and let us see how to solve this. So there will be n objects and a knapsack. Totally n objects. A knapsack has a capacity of m kgs, for example. M is the capacity of the knapsack. Object I has a weight of Wi. Each object, item number 1, has a weight of W1. Number 2 has a weight of W2. Item number 3 has a weight of W3. Similarly, item or object number 1 has a profit of Pi. So every profit we consider it as Pi. P1, P2, P3, they are the profit of the objects, and W1, W2, W3, they are the weight of the objects. Okay. Yes. Next, third point. The third point, it tells xi. Xi is the fraction of the object placed in the knapsack. For example, if x1, see x, the value of x will be is greater than 0 and lesser than or equal to 1. Either it is lesser than 0, the value of xi is lesser than or equal to 0 and is greater than or equal to 1. That means the value of xi will be between 0 and 1. Okay. And if the value of xi is 0, for example, x1, if x1 is 0, it means that that object is not considered. And if x1 is 1, it means that the object is considered as a whole. Okay. In between, if it is 0.5 or 0.25 or 0.75, any fraction, it means that that much fraction of the object is considered in the knapsack. For example, if x2 is 0.5, it means that 0.5, half, 50% of the object 2 is considered to be in the knapsack. Okay, is that clear? It's fine. So our main objective is we have to increase the profit, and that profit formula is Pi into Xi, where Pi is the profit and Xi is the value between 0 and 1. So whether it is included or not included, and if included, what portion of it is included. So that is Xi. So subjected to Wi into Xi, it means weight of each object into the inclusion or exclusion of the objects should be lesser than or equal to the capacity of the knapsack M. Now we'll take the example and we'll see. If you have, please take a pen and paper and you can solve this. Go step by step. So take a pen and paper. Um, Step by step, you just as I tell the steps, you go on writing the steps so that you will understand how you get the result for this. Okay. First, consider the problem. Consider the following instance of the knapsack problem where n is equal to 3. N is equal to 3 means there are 3 objects and m is equal to 20. M is equal to 20 means there are the capacity of the knapsack is 20 kgs, for example. It can hold 20 kgs of objects and there are 3 objects totally. The profit of the first, second and third objects 25, 24 and 15. These are the profits. And the weights of the first, second and third objects 18, 15 and 10. So this is the given problem. So now we have to um, see how it is solved. So first step, object. Let us, I'll write it as object 1, object 2 and object 3. Okay. Next step. Oh, wait for a second. So object 1, object 2 and object 3. So we are in the first step. So below that write the profits of all the 3 objects 25, 24 and 15. So these 3 write it below this 25, 24 and 15. And weight of the 3 objects. So it is given here 18, 15 and 10. So it is 18, 15 and 10. So these are the weights of the objects. Okay. Now the next step. Next step is we have to calculate P by W. P by W is profit by weight. So understand this clearly. Item number 1 has a profit of 25 and its weight is 18. That means for 18 kgs, the profit is totally 25. Now we have to calculate what is the profit for 1 kg. Okay, the profit for 18 kg is 25. The profit for 1 kg is nothing but profit by weight. Is it clear? Yes. So we have to calculate profit by weight for all these 3. So 25 by 18, it gives 1.38. You can calculate that. 24 by 15, it gives 1.6. 15 by 10, it gives 1.5. So these are the profit by weights. That means it is the profit for 1 kg for each of the objects. So object 1 for 1 kg, the profit is 1.38. For 1 kg, it is 1.6. For 1 kg, it is 1.5 for object number 3. Okay, now we have calculated this one. The next step is we have to calculate x. X. In the previous step, I told that the value of x ranges from 0 to 1. Either it can be 0 or 1 and any value in the middle. If it is 0, it means that it is included, the object is included. If it is 1, it means that the object is not included. Okay. Now, what you have to do from the previous step? From this step, you are supposed to take the biggest profit by weight. The biggest profit by weight is 1.6. You have to first consider this 1.6. So now, if you consider this 1.6, what it tells is this tells that you are considering the object number 2. Object number 2 is considered first. Okay, and you are putting that object number 2 in the knapsack. Is it clear? The object number 2 is put into the knapsack because it is having the biggest, largest profit by weight. The next step. So since you are considering, so now the next step is, next thing what you have to do is, you have decided to include the object number 2. Now what portion of it has to be concluded, whether to consider full or a fraction. So now look at the weight of that. What is the weight of object number 2? It is 15. And the maximum the size of the knapsack is 20. Maximum size of the knapsack or the capacity of the knapsack is 20 kgs. And object number two's weight is 15 kg. So what you can do, you can put this 15 kg object in a 20 kg knapsack. That means you can take this as a whole. Since you are taking this as a whole, you can write it as 1. 1 tells that you are taking the object number 2 as a whole to be considered in the knapsack. Okay, then so that is finished. So now out of 20, you have considered 15. So remaining is 5. That means you can put an object of 5 kgs, isn't it? Okay, now let us move to the next one. So next biggest profit by weight is 1.5. So next biggest weight is 1.5. So that means what you have to consider object number 3 now. Okay, object number 3 has to be considered. Now look at its weight. Object number 3's weight is 10. But what is the remaining weight in the knapsack? Only 5. It can hold only 5. But there are 10 kgs of object number 3. Now what you have to do is you have to consider only 5, and hence it is to be written as 5 by 10. It is 5. You are considering 5 kgs out of this 10 kg. 5 kgs are to be considered out of the 10 kg of object number 3. So that is why you are rating 5 by 10. Okay, you are considering 5 kgs here. You are considering 15 kgs of object number 2. So total it is 20 kgs. And since it is 20 kgs, the knapsack is now full. So, and hence the third one, that means the least one, you are making it as 0. 0 tells that you are not considering that particular object. Object number 1 is not considered. Okay, let us move to the next step. So now we have got the value of xi. Xi is 0, x1 is 0, x2 is 1, and x3 is 5 by 10. Okay, now let us move to the next step. Yes, let us move to the next step. Pi into xi, calculate profit. Calculate the profit now. What is the profit for this? Profit is Pi into xi. So profit is 25, and xi is 0, isn't it? So xi is 0. So what if there is a total is 0? We have got 0 for this. This is 0. So next, the second one. So what you have to consider? You have to consider the profit 24. 24 into xi, 24 into 1. 24 is pi, xi is 1. Okay, this is 1. So 24 into 1 is 24. The profit is 24. Next, pi into xi for the third object, the profit for the third object. So what is the profit? Profit is 15. 15. What is xi? 5 by 10. 5 by 10 is nothing but 0.5. 0.5 of 15. Half of 15 is 7.5. Isn't it? So now the total of this 24 plus 7.5, you get 31.5. That means the total profit that you can get from this problem is 31.5 kgs. Okay, and you're going to include two objects, object number 2 full and object number 3 half. So that is how you have to solve the problem. Wi into xi, the last part, you have to check whether the weight exceeds 20 or not. You have to check. You can use this Wi xi formula and you can check it. What is Wi? W is 18. W1 is 18. This is 18. And x is 0. 18 into 0. So that is 0. Object number 2. Object number 2's weight, it is 15. 15 into 1, it is 15. Object number 3, its weight is 10. 10 into 5 by 10. 10 into 5 by 10 means it is 10 into 5 by 10, it is 5. It is 5. Okay. So totally 15 plus 5, it is 20. 20 is lesser than or equal to m. M is at 20. So from this problem, we got the profit of 31.5 and total weight is lesser than or equal to 20 kg. So these are the steps to solve knapsack problem. Okay.